Okay, welcome to the second video on this particular section of rates. We've got a number of different kinds of word problems that we're going to solve, but I do want to do example number 4 at the top of page 32. This one I didn't do on the last video, and this goes back to a little bit more practice on conversions that we did on page 31. So again, we're trying to get from feet in seconds to how many miles in an hour. So this is the first one that we've done in this section, although we did some last year, where we're actually converting two different units. We're going from feet to miles, and we're going from seconds to hours. So it's going to take us more than one conversion step to actually get there. But again, it's going to be straight multiplication. We're going to start with what we know. We have 100 feet in 3.1 seconds. Because we have two units here, we've got a unit in the numerator and a unit in the denominator. We're going to write it like that. And now we're looking for a multiplication factor that's got feet and ultimately miles and hours and seconds. So it doesn't really matter whether you start with trying to get the feet and the miles taken care of first or going from the seconds to the hours. I'll start with the feet and the miles. You may not know these conversions off the top of your head. You have a lot of resources available to you online. You can Google it very quickly. I hope you do come to learn some of these common ones, though, because that will be helpful to you. 1 mile is the same as 5,280 feet. Again, I put the feet in the denominator so it will cancel nicely with the feet that's in the numerator up there. Because if you have it in the numerator and the denominator, it cancels each other out. So that gets us to miles, which is great because that's what we're looking for. But now I've got to take care of getting these seconds to hours. So again, I'm just lining up another conversion factor. I'm going to clean it all up at the end, but I want to get my multiplier set up first. So an hour, if you know how many seconds are in an hour, you can do it all in one step. If you want to go from seconds to minutes and then minutes to hours, you can do that. I happen to know that there are 3,600 seconds in 1 hour. So I'm going to do it all in one step. So again, I put the seconds on top, so it will cancel with the seconds in the denominator over here where we started. So I now look at the units I have left. Let me move that guy. I've got miles. Check, check. That's what I'm supposed to have. I've got hours. That's what I'm supposed to have. Now, this thing's got to get cleaned up. So you need to take the numerator and multiply straight across, which gives you basically 3,600 times another 100, add 2 zeros, divided by whatever 3.1 times 5280 is. This is hours, and this is miles. These are our units that are left. Clean it all up, and you get, it says round to the nearest mile per hour. I think it's approximately 22 miles per hour. So that was another example of unit conversions, and we'll do more of those on your practice sheet. Now we're going to skip down to the next kind of problem. This is a little bit different. These charts are going to be new to you for using in solving these rate word problems, but I guarantee you will grow to like them after you've done it a few times. So generally speaking, our chart that we're going to make is going to involve either 2 or 3 rows and 3 columns. I put the third row in here because a lot of times you will need a row for total. Not always, but I usually just go ahead and add it when I'm making my skeleton chart. So in each one of these problems, you're going to have what I call players. You're going to have nickels and dimes. You're going to have east and west, like in this particular example. You're going to have apples and pomegranates. You're going to have players, and they are going to represent quantities in your word problem that have different rates associated with them. So in this example, eastbound and westbound, and this is just a shell, but eastbound and westbound are my two different players, and they've each got their own rate, kilometers per hour. They've got a quantity, an amount of these hours, and ultimately you're going to always multiply these guys together to get you the total. So when we're doing our rate in this column right here, the quantity right here, this guy is always going to be the same thing as the denominator here. So it's going to cancel nicely, just like it did in our conversions. So when you multiply straight across, you're going to have kilometers, however many they are, times whatever your quantity is, and you're going to end up with the correct unit in your total column over here. So basically, you can read this as well as I can read it, but you've got the players going here. The first column is going to be your rate, your unit of rate. The second column is the rate's denominator, which is going to be a quantity. And then you're going to get your third column by multiplying these first two. So let's look at an example. I think it'll be easier to see in this example. So you've got Maria. She's working two different kinds of shifts. Sometimes she'll work an 8-hour shift, and sometimes she'll work a 6-hour shift. So those are our two players, two different shifts. So it gives us a relationship. It says she worked twice as many 6-hour shifts as she did 8-hour shifts for a total of 280 hours. That's important. We're going to use that as well. So basically, if we go to fill in our chart, we've got the 8-hour shift and we've got the 6-hour shift. We've got a total column here. And this, your rate is 8 hours. There's the word per right there. So this is hours per shift right here. This is the number, the amount of shifts. Amount of shifts. So we need a variable because we're going to have to write an equation. There's something we don't know in here, and that's what we're going to be looking for. We need to know the number of each type of shift that she works. How many did she work? So I generally will write a let statement, and I will let x equal generally almost always the smaller number. So it tells us that she worked twice as many 6-hour shifts as she did 8-hour shifts. So I'm going to let x equal the number of 8-hour shifts because she didn't work as many of those. Then to represent how many 6-hour shifts she worked, I can just double it because it said she worked twice as many 6-hour shifts. So 2x then is going to represent the number of 6-hour shifts. This is a real important part of these problems. You've got to remember what your variable stands for. You're going to get busy. You're going to get down here, filling in these boxes. You're going to write an equation. You're going to solve, and you're going to end up with x equaling something. You need to be able to go back and say, what was that x? What did I let x mean to me? So I set this up right off the bat. So if we go over here, we go in the 8-hour shift, there are 8 hours in the shift. Duh. How many of those did she work? Well, that's our x right there. We don't know how many she worked. We're going to figure it out. The 6-hour shift, again, how many hours in the shift? 6. Yes, sir. And how many of those did she work? 2x. So there is your setup. And then the quantity of hours is going to go in this third column when you multiply. This is a multiplication problem every single time. So you can do this if you want. So 8 hours times how many shifts she works gives you the amount of hours that she worked. 6 times 2x gives you the amount of hours in all of the 6-hour shifts that she worked. And then this total column, this is where this 280 comes in, because we know however many hours she worked in the 8-hour shifts plus however many hours in the 6-hour shifts gives you a total of 280 hours. Now we've got our chart filled in and we're ready to write an equation that we can solve. And it's pretty simple because we just said it. This plus this equals this. So the number of hours in the 8-hour shifts plus the number of hours in the 12-hour shifts has got to total 280 total hours. So when we go ahead and combine our like terms and solve this, we get x is equal to 14. 14 what? I've been really working hard to try to get this set up, and I'm real proud of myself of getting x equals 14, but I've forgotten. I don't even know what this means. Oh yeah, I can go back up here and I'm going to say x. I know, that's how many 8-hour shifts she worked. So she worked 14 8-hour shifts. So this is 14 8-hour shifts. And if you double that, 14 doubled is 28. That's how many 6-hour shifts she worked. And that's the answer to your question. Here's the question. Find the number of each type of shift she worked. So I know this is a little bit different. If you need to go back and listen to this video again before you move on to another problem example, please do. But we are going to work some more of these, and I'll have a couple more examples in the next video. Bye-bye. Come back.